Remember scientific notation, where instead of having to write a whole bunch of zeros, we'd express maybe a very large number as something like 5.42 times 10 to the 19th? How do we determine how many significant figures are in a number like this expressed in scientific notation? Well, you know what? It's not that hard. It's really easy. And all we have to do is completely ignore this 10 raised to the exponent. The only thing we want to do is we want to pay attention to this part here, which we call a mantissa. I didn't make that up. It's actually a word. You can look it up. But so all we want to do is concentrate our energy on the mantissa here. Okay? So 5.42, all of them are non-zero digits, which means that this number has 3 significant figures. That's it. We don't pay any attention to the 10 raised to the 19th. We cross it off when we're looking at how many significant figures a scientific notation expression has. Okay, similarly, let's say we had 7.100 times 10, I don't know, to the negative 8th. Again, we don't worry at all about the 10 raised to the power. We look only at the mantissa. We look at the mantissa. 7.100, the zeros are significant because they're to the right of a decimal place. So 4 significant figures in the mantissa, which means that there are only 4 significant figures in this number. Do not let this 10 to the whatever power confuse you. All you have to do is look at the number on the right. Okay, so let's take a look at how we do some math problems with significant figures in scientific notation. Okay, here's a division problem. We do division and multiplication the same way. Okay, I'm just going to do one example. So here we do 2.0 times 10 to the 12th divided by 8.33 times 10 to the 8th. As we've said before in scientific notation, the first thing we want to do is we want to break this problem down into 2 smaller problems. Okay? The first thing we're going to do is we're going to take 2.0 and divide it by 8.330. Okay? So 2.0 divided by 8.330. And when I do that math, I get 0.240096. Okay? That's the first part of this. Now, significant figures. How do we round this? We pay attention only to the significant figures that are in the mantissas of these numbers. Okay? So 2.0, 2 significant figures, 8.330, 0 coming to the right of a decimal place, 4 significant figures. We round to the lower number of these, so 0.24. Remember, this isn't significant because it's coming to the left of a decimal place, so we don't have to worry about that. 0.24. I'm going to keep these. We're going to look to the right. Do I keep it the same or round up? It's a 0, so I keep it the same. 0.24 is our answer, rounded to 2 significant figures. And remember, when I did this and when I did the significant figures here, and then the math, and then the rounding, I didn't pay any attention to these 10 to the 12th, 10 to the 8th. It doesn't have anything to do with it. Okay? Now, for the second part of the division equation, we are going to look at the 10s raised to the power. So we're going to do 10 to the 12th divided by 10 to the 8th. When we divide numbers, we subtract their exponents. So we do 12 minus 8, which is going to give us 4. So the answer to this division problem is going to be 10 to the 4th. Okay? And again, we don't worry at all about significant figures when we're doing this half of the problem. So, is this going to be our final answer? 0.24 times 10 to the 4th. It's not, because if you remember, correct scientific notation is always written where we have 1 digit, and then the decimal place, and then all the other digits. So we want to have 1 digit to the left of the decimal. Here we don't have any important digits to the left of the decimal. We have a 0. So what is now 0.24, we want to change this to 2.4. In order to do that, I have to take the decimal place and move it over 1 spot to the right. When I move decimal places over to the right, I take the exponent of 10 and I move it down. So since this was 1 spot, I'm going to go from 10 to the 4th, 1 down, to 10 to the 3rd. Now my answer is in correct scientific notation, and it also has the correct number of significant figures. Okay, so just to quickly recap what we did the division here. We paid attention to significant figures just like we normally would, and in doing this rounding, we paid no attention to to the 10 to the 12th and 10 to the 8th. Don't let it confuse you. It's not important at all. Just do the division or the multiplication. It's the same, just like you would any other problem, and then add on the 10 to the whatever power after you finish it off. Figure it out at the end. Okay? So this is division. The same would be true for multiplication. Let's look at addition and subtraction, because they have some different significant figures rules. Now, in scientific notation, when we're adding or subtracting numbers, the powers of 10 have to be the same. And you can see that here. 10 to the 4th here, 10 to the 4th here. That means we can just add them up. As we said before, we're going to break this into two different problems. The first thing I'm going to do is 2.113 plus 9.2. Okay? I'm going to add this up. Do the math. 3, 1, 3, 11. Okay. Remember, the rules for addition and subtraction with significant figures are somewhat different. I find which of these numbers here has the fewest places after the decimal. It's here. It's the 9.2, which means that I draw a line right next to this, and this shows me where I'm going to round. I keep the 3. I look to the 1. Do I keep it the same or round up? It's a 1, so I keep it the same. 11.3 is this first half of the equation. I paid attention to significant figures here, and I didn't pay any attention to the 10s raised to the power when I did this part of it. Okay? Since it's addition and subtraction are the same, we just keep this 10 to the 4th. We don't change it at all. We don't like add it. We don't subtract it. It's just 10 to the 4th we started with. 10 to the 4th is what we end up with. Only for addition and subtraction. Okay. So here's the answer that we get. Is this correct scientific notation? No, it's not, because we want to have one digit, decimal, blah, 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 blah. So 11.3, I want to change this to 1.13. And in order to do that, I'm going to have to take the decimal place, move it over one spot to the left. Now, when we move a decimal place to the left, it means we take the exponent on 10 and we increase it. In this case, we moved the decimal place one spot over, so we increased 10 to the 4th up by one spot to 10 to the 5th. And now here is my final answer, incorrect scientific notation, and rounded to the correct number of significant figures. So we do the math, addition, subtraction, multiplication, division, just like we would any other problem, paying attention to significant figures, not worrying at all about the 10 to the whatever power, round it, and then we make sure that our final answer is in correct scientific notation. But that is scientific notation and significant figures.